Let's solve an easy combination circuit problem to find the voltage across a resistor. This is a great starting point if you're learning how to deal with series and parallel components in one circuit. Here's the setup. A 12-volt battery powers a circuit. There's a 4-ohm resistor R1 in series with a parallel pair of resistors. R2 is 6 ohms and R3 is 3 ohms. Our goal, find the voltage across R3. Start by simplifying the parallel part. To find the equivalent resistance of R2 and R3 in parallel, use the formula 1 over R equals 1 over R2 plus 1 over R3. That's 1/6 plus 1/3, which is equal to 3 over 6 or 1/2. So R2 and R3 combine to make a 2 ohm equivalent resistor. Now, this 2 ohm parallel section is in series with the 4 ohm R1. So the total resistance of the circuit is 4 plus 2, which gives us 6 ohms. In step 3, we calculate the total current using Ohm's law. That's V equals I times R. Rearranged, I equals V over R. So 12 volts divided by 6 ohms gives us a current of 2 amps flowing through the entire circuit. Next, in step 4, we need to find the voltage drop across R1, which is in series. Multiply current by resistance. 2 amps times 4 ohms gives us 8 volts across R1. Therefore, the remaining voltage drops across the parallel part, R2 and R3. The total voltage is 12 volts. Subtract the 8 volts across R1 and you're left with 4 volts. That 4 volts is shared across both R2 and R3 in parallel. Now here's the key point. In a parallel network, all resistors experience the same voltage. So the voltage across R3 will be 4 volts. That's your final answer. So to summarize, simplify the parallel section, add up the total resistance, use Ohm's law to find the current, then walk through the voltage drops step by step. The final voltage across R3 is 4 volts. If you like content like this, visit us at voltagelearning.com and don't forget to like, comment, and subscribe. Until next time, we'll see you guys later.